This is a video for AP Physics, free response number 2 from the fluids packet. And I've already set everything up here just to make this go pretty quick, because this is just to get you unstuck if you were stuck on this problem, and to show a slightly different way to attack it than what the key did. Okay. All right. Oh, also, I cut my hair at home, and a thunderstorm has hit while I was doing it earlier. And so if you think things look weird, yes, they do. Okay. It's kind of comical. My family got a big laugh out of it. I'm not done. All right. So let's go ahead and take a look at this, if it'll zoom out correctly. There we go. All right, so first off, we've got this crown. There's my attempt at drawing the crown. Okay, and it's just hanging from a spring scale. So we have forces scale up, force of weight down, and those will obviously be the same thing if it's just hanging out there in the air. We don't have to worry that much about the buoyant force of air. There is one. We're pushing air out of the way. It's just insignificant compared to the weight of a crown. Okay, so we have force of weight, and then we can also get the mass. Okay, so we can get both those things. This was directly given. This is just that number divided by 9.8 to get the mass of this crown that we're trying to figure out if it's real gold or not. Okay, so now we hang it from a spring scale, and we put the crown in water. And here's my free body diagram for that. So we've got, let me zoom out a little bit. We've got force of scale going up, force of buoyant force, because now it probably is significant. We're pushing that water out of the way instead of air. That's probably going to be a decent sized number. In fact, we know it is based on the change of the reading of the scale being significant. And then we've got still the same actual weight going down. So the actual weight going down hasn't changed just because we put it in water, right? Okay, the reading on the scale will change because we have this extra support force here in the buoyant force because we're shoving all that water out of the way. It's all trying to get back in, which results in our buoyant force going up. Okay. All right, so I went ahead, since this is a free response question, I want to show a little bit of my work just to make sure I get the points. So I show my summing forces in the y direction equals 0. The three things, scale and buoyant force going up, weight going down, and then solve for buoyant force. I have the numbers right here, and I'll get 4.49 newtons. So that's the actual buoyant force acting on the crown. All right. So I was like, okay. Oh, and the way I attacked this problem, I was just like, okay, I'm looking to figure out if this is real. They're putting it in water. It's going to have something to do with buoyant force. So I started summing. I wasn't sure, didn't see exactly what to do, didn't remember off the top of my head. So I'm like, well, I'll start drawing free body diagrams and summing forces, like we would do on many problems that have forces. It seemed like a good place to start. And then once I got the buoyant force, I'm like, okay, I can figure out some more information about this crown, which would be the density. Because I have the buoyant force. I have the density of water, because they said it was in water. Water has a density of approximately 1,000 kilograms per meter cubed. That was not given in the problem, but free response questions in the past have allowed you to use that if it's fresh water, even if it wasn't given. So I feel like that's fair game for this. If they had said salt water or something like that, I would have had to have done this, or some unknown fluid or liquid. I would have had to have done this in terms of density of the water and done a little bit more algebra to get this to work out. Okay. And then, oh, there's some more thunder. And then there's the volume of the fluid displaced, which will be the crowns pushing the water out of the way. So that will be the volume of the crown in this case. So this is the density of the fluid that's been shoved out of the way. This is the volume of how much of that fluid, in this case the water, has been shoved out of the way, which will be the volume of the entire crown. I'm assuming that it's completely submerged. I think it said that in the question too. Okay. All right, and then here we have the, well, it would float otherwise, and the reading on the scale would be 0, right? So it's definitely completely submerged. And then here is our acceleration of gravity, 9.8 meters per second squared. So I can directly solve for the volume of the crown. Okay. So now, when I got to right here, I was like, okay, well, I got to use that information to figure out if it's real. So I went ahead and wrote down what they gave me in the problem, that the density of gold over the density of water equals 19.32, that ratio, which means I know the density of gold now is that times the density of fresh water, which is 1,000. So move this over 1, 2, 3 places. So 19,320 kilograms per meter cubed for the density of gold. Okay, it's like, all right, so I need to go ahead and get the density of this crown and then compare. Well, density is mass over volume, and I already have the volume of the crown that I can solve for from here because I know all those numbers. Okay, and I have the mass of the crown from the very beginning of the problem when I just took this original weight and divided by 9.8. All right, so I took those two numbers. There's my mass, and then this volume that I didn't write here, but I solved for that volume, and divide them, and I get 5,600, about 5,600 and 11 kilograms per meter cubed. This is nowhere near gold, right? Okay, this is way less dense than gold, so it's not gold. It's something else. Okay, if it was more dense than gold, we would also say it's not gold, but we're not even close to that number that they said that we were supposed to get. Okay, so this is a little bit different than the way they did it. Again, I would have had to have done more algebra, probably more like what they did, if I didn't know the density of approximate density of fresh water, 1,000 kilograms per meter cubed. If this didn't clear things up, this approach, just send me an email and I can give you some more direct instruction via email, or maybe record another video if necessary. Okay. All right, that's it. Have a good day. Look at this. Look at this nonsense. It's awful. Absolutely awful.